Drawing out the facts, the Naked Science Scrapbook. Hello and welcome to the Naked Science Scrapbook. This time we'll be answering the question, how does a light bulb work? When you get up in the morning or come in from school or work in the evening, one of the first things you probably do is switch on a light. We take them so much for granted, but how do they work? Firstly, let's look at an incandescent bulb, what most people would think of as the stereotypical light bulb. If you look closely inside the glass, you should see a thin wire, and if you look even closer, it's actually an even thinner wire that's coiled up, and then these coils are coiled up. When you turn on the light, electric current flows through the wire and heats it up, just like an electric heater. As something heats up, it first gets red hot, glowing red, then it glows orange, yellow, and then at about 2000 degrees centigrade, it'll glow white hot. The wire in a bulb has to be made of the metal tungsten, which is one of the very few substances which won't melt at this high temperature. But if it was exposed to the air, it would really quickly react with the oxygen, i.e. burn, to form tungsten oxide smoke. To stop this from happening, the bulb is filled with a non-reactive gas called argon. The problem is that although a light bulb gives out visible light, it also gives out large amounts of infrared light. This is an invisible colour of light beyond red in the spectrum, some forms of which thermal cameras can see. If you look at an incandescent bulb with an infrared camera, you can see that it's actually much brighter in the infrared than in the visible spectrum. So it's using 90% of its energy producing light that we can't even see, which isn't very efficient. Another type of light bulb that's promoted as energy saving because it converts electricity to light more efficiently is the compact fluorescent lamp. A compact fluorescent lamp, or CFL, is made up of an electrode in a tube full of, again, an unreactive gas, but also with a small amount of mercuryvapor. Mercury is the liquid metal that you find in thermometers. When you turn the lamp on, a large voltage in the electrodes rips some of the electrons off the gas atoms. These moving electrons bash into the mercury atoms, transferring energy to them. This energy is then released again in the form of ultraviolet or UV light. This is the invisible form of light at the blue end of the spectrum, which makes your clothes glow in a disco. This effect is called fluorescence. Your clothes absorb invisible ultraviolet light and fluoresce, emitting the light again in the form of visible light. The white powdery substance on the inside of the glass of CFLs does exactly the same thing as your clothes, making the tube glow white and produce the light that you see. So there's actually a whole lot of science going on when you switch on that bedside lamp. That's it for this time. To get the answers to more science questions, join us online at thenakedscientist.com/scrapbook. Bye!